and show. Hello and welcome back to Calculus 1. We're talking about definite integral. So in the last lecture, 5.1, we defined the definite integral through Riemann integral, and we already know that the definite integral is calculating area under the curve. So the definite integral, which is integral a to b f of x dx, is defined through the limit n goes to infinity, summation I goes from 1 to n, f of xi delta x. Now we are interested in, and all of that gives us the area, right? We are interested in learning how to compute this definite integral, and that will be given by integral a to b of f of x dx is equal to any antiderivative computed from a to b, which is f of b minus f of a. Example, integral from 0 to 3 of square root of x dx. You are going to solve integration part in the same way you solved integration in 4.9. We are going to rewrite this problem as x to the 1/2. We are going to use the formula x to the 3/2 divided by 3/2. But now we have to put this vertical line which says compute from 3 to 0. So these 3/2 in denominators become 2/3. And what I have is 3 to the 3/2 minus 0 to the 3/2. This is the part of f of b minus f of a. Yes?
By a capital F.
Antiderivative. That's the solution to the integral. So the derivative of capital F is the lowercase f. Yes, Brian?
Where did you get the 2/3 from? Okay. Say no more.
So what I have is 2/3 times 3 to the 3/2. Now you can take the calculator and get the decimals. I'm just going to leave the exact answer there.
We can leave that down test it, right?
Yes.
Yeah.
Calculate the you guys calculate the definite integral from 1 to 3 of x squared plus 2x minus 1 dx. You know how to integrate all of these. The new step you are learning is how to compute the limits of integration.
Wait, what's that straight line mean?
Computed x. That's the name. It means compute x 1 to 3 in this case. It's a mathematical notation that stands for compute x.
Oh yeah, you already just noticed shooting?
Wait, what?
Are you guys doing the problem or are you partying?
I'm doing it. I can do either one, bro.
What's that timeline there? Shoot me.
See? Oh, come on.
Oh my god. I didn't get it close.
Sorry. I don't know who made that, dude. Was it you?
Was you? No.
It was, if it was Shubi, thank you.
Thank you. Sad. Yeah, it's most sad.
Okay.
Alright, guys, leave me alone.
I'm doing my work. I don't know what you guys love. It was solid.
That's Shubi. Mental.
Oh.
Yourself is just a different way of thinking from
Right, so let's integrate.
Yes.
What's the integral? x cubed over 3 plus x squared minus x computed from 1 to 3. So vertical line is just a notation which you read computed from 1 to 3. So I am going to plug 3 into the entire expression. And then minus, we plug 1 into entire expression. And then you just compute. So what do we get? Oh, come on.
Man.
What happened?
I guess we
Now
just need to skip it.
What happened to the 2?
Ah,
What happened to the 2?
it's x squared over 2. And they cancel.
Like integral of f of like kfx, not equal to f integral of fx. We bring it out.
Yeah, but it will be, the answer would be x squared over 2. X squared over 2.
You gotta get over. Oh, so the 2's cancel.
Yeah.
You gotta get the angle.
And then 2's canceled, yes. So 27 over 3 is 9. Plus 9 minus 3 minus 1/3 minus, these guys cancel actually, so like that's 1 minus 1, so that's done. So that's 18, 15, 14 and 2/3.
So that's automatic. Does that mean that's the area of that?
That's the area under the curve. What happened?
You're a genius.
He's just trying for those extra
It's extra points.
Dude, I got like
All right, guys. The next question is, we know that this can be used for the area, right? So let's say you are tutoring someone in middle school. They can't recall the formula for area of the triangle, and you tell them what the formula is, and they go, why? Here we go. So what is the area of this triangle where this point is 3, this point is 6? What is it? What's the area? 9? All right, let's see. So you're claiming that the area is 9 by some magic. You haven't done any work, so you might be copying from someone. Maybe you prayed for the answer, I don't know. Let's see. Let's see what works.
Yeah, but isn't it a simple area formula half base times height? Well, because it's still a unit, it's still, so wouldn't that be the only word to use?
Let's see.
I don't know about that.
Area, we find area when we integrate from a to b f of x dx. This line over here is your f of x, and that line is the linear line, which we can observe that the slope is negative, and it's rise 3 over run 6x plus y-intercept 3, which is the b, right? Y-intercept. So all I need to do is to integrate from 0 to 6, negative 1/2 x plus 3 dx, and that will give me the area, right? So when I integrate, I get negative 1/4 x squared, because it would be x squared over 2, and then half times half, right? Plus 3x computed from 0 to 6. And then I plug everything in. I get negative 1/4 of 6 squared plus 3 times, maybe I should go next line. Negative 1/4 6 squared plus 3 times 6 minus, and now we're computing at 0. 0 is just going to kill everything, right? So I'm just going to put the big fat 0 there. 6 squared is 36 times 1/4 is negative 9 plus 6 times 3 is 18, and the answer is 9.
Why is it a quarter? Where did you get that from?
Oh, because of the x to the whatever equals Professor then.
X to the n plus 1 over n plus 1 and
right?
dx.
I don't really have to
integral
include that.
kx equals k integral
That line
x.
doesn't put
So
6 and
basically,
0. I have to include that.
That's official notation.
What about if
Times
there's
1
no
half.
there?
So half x
What?
squared times
Like
half.
what about, because you know it's 3 times 3.
The next problem we want to see is what is the area under. So we can compute any area given the function, right? So let's compute area. Let's get something from the textbook, and then I have to talk about specific cases. Brian, right here.
I think he expects it, man.
Integral of negative 4 minus x cubed dx from 3 to 7. This is problem 12 in the textbook. So work this one out on your own.
Is that x to the 5 or x to the 3rd? X to the 3rd.
Plus c.
Great question. What happened to the plus c, and why don't we have the plus c? Observe this. I'm going to erase it. What happens here is that when we integrate f of x dx, we are going to get antiderivative plus c computed from a to b. So now that's going to be f of b plus c minus f of a plus c. The minus distributes and the c's cancel, which is the reason why we don't put plus c for definite integrals. So if you have limits with numbers, you don't do the plus c because it will cancel every time when you do the calculation. So we just ignore it. Yep. So when you have these numbers, you don't put plus c. If you don't have the numbers, then you have to put plus c. If you're provided with the initial condition, you will calculate the value of c. What's the integral of negative 4? Very good. What's the integral of negative x cubed? Great. So we have negative 4 times 7 minus 7 to the 4 over 4 minus, open parenthesis, negative 4 times 3 minus 3 to the 4 over 4 equals negative 28 minus, that's a 49 squared over 4, minus and minus gives us plus 12, plus, that's 81 over 4. So that's what we have. Now 28 minus 12 is negative 26. plus 81 over 4, and I still have minus now 49 squared. To compute 49 squared, you will multiply 49 times 50, because that's the easier way to do it. But then why not 490 divided by 2? That's even easier. So 490 divided by 2 is going to be the 245. And now it's so 245. So we have a 245, and then we have to subtract 49 from it, because we went 149 over, and we'll get 196 over 4. Or you can use calculator. What happened? I said 49 squared. Wait. 49 times 50 is the same as, 49 times 100 is 4900. Minus 49 is 4851. There we go, much better. All right, much better. Did I forget to do? I did divide it. So that's 2450, and now minus 49. There we go. 2411. No, 2101. I give up. There we go. That's my final answer. There we go. Much better. Times 4. Is that negative 104 over 4? Plus 81 over 4 minus 2401 over 4. I have 81 and this one. When you combine, you get negative 2320 minus 104. Negative 24. Oh no, these are all, you can cancel by 4. You can cancel these by 4 now. So 4 into 23 goes 5 times. And then into 32 goes 8 times. And then it goes 26 times. Negative 606, I hope. Now the beautiful thing about technology is you can plug this into Mathematica and verify if you... Most of this is calculation. Guys, calculus was done right here.
How though? How would you make that symbol in Mathematica?
Which one?
The integral...
Oh, you just talk to it. All right, so the next thing is to take a look at how to check these problems. And we'll continue this lecture tomorrow. So when you start up Mathematica, come on, there it is. All right, guys, look. You go to Wolfram Alpha Query. And you say integrate x squared from 2 to 7. Enter. So just talk to it. This is why it's so powerful and so awesome. Done.
Well, that's why I always mess up. I always try and do like correct sign with parentheses, but if I just write from, it's so much easier.
Yep. So I'll see you all tomorrow.
So we go home.